Hello everyone and welcome to another SQL session with Learn at Knowstar. While writing a SQL query, it is a common requirement to combine data from different tables. So it is very important to understand the concept of SQL joins. In today's session, we are going to explore the different types of joins and how using a specific type of join will affect your output dataset. So let's get started. So we are going to work with very basic tables, employee and department to understand these different types of joins. I already have run some select queries on these tables. So you can see that there's 7 records in the employee table and then there are 4 department records. Now, if we want to take a closer look at this data, I have pasted this data in an Excel spreadsheet. So there's some key observations that we can make out of this data. The first thing that we observe is that the join between these two different tables can be made on the department ID column. So let's go back to our SQL server and we can see that there's a column called department ID and there's also a column called department ID in the department table. So this is the common key column on which we are going to make all the joins. Now, our first observation that we can make out from the employee data is that employee ID 6, so Mark Miles, he has not been assigned any department, and employee ID 7, which is Jenny Jeff, has been assigned a department 999, so it seems it is an invalid department because it does not exist in the department table. Another thing that we need to observe over here is that the department 104 over here is not assigned to any employee. So all of these employees are assigned departments from 101 to 103, but 104 has not been assigned to any department. So we'll see based on the requirement how we can use a particular kind of join to fetch the necessary information from both of these tables. So let's get started. So the first kind of join that we want to see is an inner join. An inner join is used when we want to fetch matching information from both the tables on which we are performing the join. So let's get started with writing our queries. So now what I want to do, I want to fetch all the employees. So I'm using a select from the employee table. And then I'm going to make an inner join. So simply write inner join on the table department. And I'm going to give them aliases. So this is emp for employee and dept from department. And then I have to specify my column on which I want to make that join. So that column is obviously department ID. So employee dot department ID equal to department dot department ID. I'm going to execute this query. And what I've got in the output is basically all the employees who have a valid department associated with them. So I have got 5 records in my output. If I go back to my base tables, I can see that there were 7 records in my employee table. But out of these 7 records, only 5 employees were assigned a valid department or a matching department ID from the department table. The other 2 employees were not assigned a matching employment ID. And that's why I have got only 5 records in my output. So this is how an inner join would work. An inner join would give you matching records from both these tables. All right. So to understand it through a Venn diagram, how can we understand it through a Venn diagram? Let's see. Let me just increase the size. Let's go above here. This is how these different kinds of joins can be represented using Venn diagrams. So here you can see that there are 2 tables A and B. So in our case, A is employee, B is department, and only the matching records from both of these tables will be returned as an output of the inner join. Now, moving on to the next kind of join, which is the left join. So left join would be used in scenarios when we want to fetch all the records from the left table, or let's say the master table, and only matching records from the child table or the right table. So in those scenarios, we want to use a left join. So for our example, it would be that we want to fetch all the employee records and only the matching department records. So I do not want to filter my employee records. I want all the employee records and the associated valid department names with those records. So let's go back to the SQL server to write a query. Okay, let's go back to the tables first and let's take a look at the table. So what are we saying? We are saying that we want all the records from the employee table. So I want all these 7 records from the employee table and only the matching records from the department table. Now match is made based on the column department ID. So the matching records would be only between 101, 102 and 103. 999 will not come in the output because there is no associated matching record in the department ID. And same happened with the inner join. When you performed an inner join, this particular record was left out, though it has some numerical value assigned to it, but because this department ID does not exist in the department table, so this record got filtered out. But now we are saying that we want all the records from the employee table and the matching data from the department table. So wherever there is a match, I want the corresponding department name to be fetched. But what happens for the corresponding department name column? What data would be output for these 2 particular records? Because they have no matches in the department table. So whenever we are performing this kind of a join, so let's perform this join and see what are the output results. So just change the inner join to left join. Simple syntax. In terms of syntax, it's a simple change. And we execute this query. Now what we have got for the first 5 records which had valid department IDs, we have got the corresponding department names. But for the 6th record which had already had a department ID as null, we have got the department name as null. For the 7th record which had some value in the department ID which was 999, we have got department name as null. So this is what happens in a left join. When you perform a left join for any records in the left table, which is employee in a case, which does not find a match in the right table, which is department in a case, a null value would be returned. So going back to this data over here, since these 2 records do not find a match in the department table, the corresponding value fetched for the department name would be null. Now let's go back to another kind of join. So let's go back to this Venn diagram interpretation. So we can see the left join has all the data from the table A, which is the master table or the employee table in our case, and all the matching records coming out from B. Now what happens in case of a right join? In case of a right join, we can see that all the records selected from table B, which is the child table in this case, and only the matching records selected from table A. So let's go back to the SQL server and write this query. So I'm going to change this left to right. That is the only change I'm going to make. So now which is the left table and which is the right table? If there is any confusion between these 2 tables, then whatever table we have specified, whatever is the first table in the order which we have specified is your left table. Whatever is the second table that we have specified or to the right of this join clause is your right table. Alright. So now if we run this query, what we're going to get is all the records from the right table. That means all the records from the department table, all these 4 records from the department table matched with corresponding employee information in this table. Alright, so let's execute this query and see what are our results. So if we take a look at the result now, we have got 6 records, right? We have got 6 records in the output, and we got only 4 departments. So what has happened is that whenever we had the department ID as 101, it has fetched the corresponding employee information. For 102 also it has fetched the corresponding employee information, 103 as well. For 104, so 104 we knew that there is no employee assigned to the department 104. So what it has done, it has fetched null value for the employee columns as an output, because there was no match found for department ID 104 in the employee table, right? Now, another thing that you can observe over here is that you have got multiple records for the same department ID. So whenever you are performing a join and you have multiple matches happening in the left or the right table, then all those matches will be returned as an output. So we have to take care. It might be that those are duplicate records and we do not want the duplicate records in the table. So whenever your output from your join condition exceeds the number of records from either the left or the right table, then you have to check that whether it's a valid duplicate or not in that table. Okay, so for this case, it's a valid duplicate because it is a one-to-many relationship or many-to-many relationship, because to one department ID, multiple employees can belong to one department ID. So this is okay in our case. All right. Now, another thing, let me change it back to left join. All right, and run this query. So another thing that we can observe is that we have got all these 7 records from the employee ID, and wherever there was a match which was not found for that employee department ID in the department table, we have got null as department name. So for scenarios where you actually want to find out that which are those employees for which I do not have a valid department, we can use a left join or a right join as well. So we can use a left join, and then we can add a where clause saying where department name is null, the department name is null, and execute this query. So what we have got in the output is only these 2 employees. All right. So we have got these 2 employees, and we know that these 2 employees do not have a valid department ID. So this is a valid scenario that occurs in many cases, and this is where the left joins or right joins can be used to identify the non-matching records in the other table. Now, another thing that you would observe is that if I leave it as a left join and just, let's say, change the positions of the department and employee table. So I can make it as employee now. Okay, so I can make this as employee. And now execute this query. All right, and now let me just execute. So I have taken out the where clause because we're not using it at this moment. And now if I write this query, one more query, I'm going to write. All right, and I'm going to make it again a right join. Okay, so this would be coming here, and this would be coming here. All right, so if I execute both of these queries now, what we can see is that we have got the same number of results or records in the output, and whatever we specified as the first table, the columns from those tables have come as the first in the sequence. Okay, otherwise if you take a look at the data, you would see that the data is the same. We have got the exact same result set from both of these queries. So what is the difference between left and right join? So what I have done in these queries is simply I have changed the positions of the tables and made department as the left table and employee as the right table and use a left join. And in the second query, I have made employee as the left table, department as the right table, and then use a right join. So what this indicates is that a right join can be written as a left join by just reversing the positions of the table. Then why do we need a right join? So technically speaking, there is no real purpose of a right join. There is no performance improvement as such, but writing it in a proper syntax, it just makes it easier to understand. And sometimes people want to symbolically denote the relationship as master and child. So whatever you are writing on the left of the join clause is kind of your master table, and whatever you are writing to the right of your join clause is kind of your child table. So when you want to make such kind of query, you can use a right join. Otherwise, technically speaking, you can perform the same function that a right join performs by using a left join, by just reversing the positions of the tables. All right. So Let's move on to the next kind of join. So let's go back to our diagrams which we have. So right join, you can see all the records from the right table, only the matching records from the left table. Now what is a full outer join? So full outer join, you can see in this diagram, simply says that all the records from the left table as well as all the records from the right table. So let's go back to a SQL query and let's remove this query. Okay, go up and make this as a full outer join. So if I just put full outer join, what I'm saying is that I'm going to get all the records from this table as well as all the records from the department table, which basically means that I'm going to get a corresponding department name for these 5 records. For these 2 records, I'm going to get department names as null. And then I'm going to get another record which is going to be department number 104 from marketing, and I'm going to get the employee name for that department as null. Okay, so let's go and execute this query. All right, so what we have got is we have got 8 records in the output. Okay, so what we have got is we have got all the 7 records in first place from the employee table. All right. And then we have got nulls as department names for those 2 employees for which a valid department ID was not defined. Then for the department for which there is no assigned employee, we have got 1 record created for that department, and the values for employee name, corresponding employee name, is null. So this is a full outer join. When you want to get the records from both the tables, matching and unmatched records, you can use a full outer join. For matching records, you would get corresponding matching values, and for not matching records, you would get nulls populated in the corresponding table names. All right. So again, you can use a filter over here and identify which are the matching or unmatched records based on where you have got a null value populated. Now, when we're saying that there's a null value populated and things like that, beware that nulls can also be valid values. So make sure that you're using a column to identify for unmatched records based on null values in that column, only if that column is a not nullable column. All right. Only in that condition, you can correctly identify the unmatched records. All right. Okay. So another thing that we can, let's go back to our table over here, and instead of this, let me make a department 1. So I have created some duplicate records, okay, in the department table. So now if you see the information here, you can see that there are 2 records created for department ID 103. All right, so one has the department name as ID, one has department name as information tech. So these are duplicate records on the department ID 103. Now, if you go to the employee table, there are 2 employees assigned to the department ID 103. All right. So now if I write a join, let me say I simply write an inner join. Okay. How many records should I get? What should be the value of department name that I should be getting corresponding to these employees who have the department ID assigned as 103? So let's go back and write that query and see how it would work. All right. So let's go back and create an inner join. All right, and change the department table to department 1. So it has duplicates. And now execute this query. Okay, so now what is going to happen over here is that we are going to get, okay, let us order by employee ID to make it easier to understand. All right. So now you can see that the employee Adam Owens, who had the department assigned as 103, he has got 2 records in the output. So a match has been made with both of the records that existed in the department table. So if you have duplicates in the table and they are not valid duplicates, you need to be aware of the data. All right. So in case it is kind of a lookup table or a reference table where we are just looking up the department name, obviously these are invalid records. So you can catch the number of invalid records based on the data in your table. All right. So we're using an inner join. Ideally, we were expecting only 5 records in the output because they had valid values. All right. But we have got 7 records in the output. All right. And the duplicates on employee ID created as well. So you can identify basically if your the if your output row count is greater than what is expected out of an inner join, then there might be cases where you have duplicates in your data and you need to analyze that. All right, so this is one condition that you should be aware of. Okay, now let's go back to our Venn diagram representation of the join. Now, another join that we are going to talk about now is the cross join. So these four kinds of joins that we have talked, like these are used very commonly, and you would need to use one or the other when writing your SQL queries. Another join that is less commonly used is the cross join. So cross join is nothing but a Cartesian join. So what it does, it creates all possible permutations and combinations. So let's say you want to create a combination for all employees and department, which is not maybe a valid scenario, but let's say you have a retail chain and you have a black shirt, all right, and you want to create all combinations of that with the size of the shirt. So let's say small, then medium, then large, then extra large, and extra large. So you want to create all combinations. You want to create a match with every record of the kind of size, okay, with different values of sizes. So let's go back and write the query to understand this in more detail. So this is what it is going to do. So let's go back and write that query and see how it would affect the output. So I'm just going to change this to cross join. Okay, so now when you're writing a cross join, you do not need to define any condition, because in any case, it is basically going to join every record in your table A with every record in your table B, because it is going to do a Cartesian product and it is going to give you every possible combination as an output. So you can just write this and run your query. And what is going to happen is that you're going to get 35 rows in the output, because it is department 1. If we go back and change it to department, we're going to get the 28 rows, which is basically going to be, so if I go back to department and execute this query, it is simply going to be the product of the number of records in your table A, which is employee in our case, multiplied by the number of records in your table B, which is department in our case. So it is basically going to be a product of 7 into 4, that is 28, and that is what you've got here. You've got 28 records. All right. So if you take a closer look, for department ID 101, it has matched it with every employee. All right, it has matched. You will see that 101 has been matched with all the 7 employees. Then 102 has been matched with all the 7 employees, and so on. So basically, it has generated all possible combinations possible out of these 2 tables. Now, there are other ways in which you can write a cross join. So you do not really need to put a cross join over here. What you can simply do is just put a comma, define no particular join, and just run this query and you would get the same result. Okay, another way of writing this is, instead of writing the keyword cross, you can put inner join department, and then in the condition that you need to define, you can define a condition which is always true. So something like 1 equal to 1. So wherever you see 1 equal to 1 written, that means it is a cross join and it is going to result in all the possible combinations made from these 2 different tables. All right. So this is what a cross join is. Now we have covered all these kinds of joins. There is another kind of join that pops up many times, which is the self join. So what is self join? Self join is basically a term. It's not a type of join as such. It is a term that is used to indicate joining with the same table. So now we are not going to be concerned with the department table. Let's just work on the employee table. So the most common scenario that is possible with this is identifying the employee manager hierarchy, for example. So what we need to do over here is combine the employee ID with the manager ID, which are part of the same table employee. So we need to perform a join between the same table. So what are we saying is that we want to do select star from employee, okay, and then we want to perform an inner join. Okay, we want to perform an inner join on employee as, let us say, manager on emp dot manager ID equal to manager dot employee ID. All right, so there's a detailed video that I have done on identifying the employee manager hierarchy, so you can go and check it out as well. Okay, so now if we run this query, you will see that you have got the employee names over here, and what you have got over here is your manager name. All right, so the manager for Adam Owens is Hilary Riles, the manager for Smith Jones is Richard Robinson, and so on. All right, so this is the use of a self join. It is also can be used when you want to write aggregate queries. So you want to find out the employee with the highest salary, for example, and so you have to write an aggregate query where you will be finding out the maximum salary from that table, and then you would be joining back on the employee table to get the information related to that employee. So I also put a link above to that video that we have done, so you can go take a look at that video to understand how a self join basically works. So this is again a self join. Now another thing that we need to remember about all these kinds of joins is that you can have different conditions based on these joins. So when you are saying that you want to perform a left join, okay, so left join, and you have some, let's say, date columns or something like that. So I am going to perform a left join on department again. All right, as department on employee, that department ID, and department dot department ID. Okay, so in this case, what you can do is also replace the equal to with a greater than or a less than sign. That also works perfectly with these joins. So based on your scenarios, you can do that. So it basically is not a valid scenario in our case, maybe a valid business scenario, but it might be a valid scenario in many cases, most probably when you are comparing the dates. So many times it happens that you want to compare a date is lesser than or greater than a particular date from another table. So in that cases, you can use different equality operators as well. So it is not necessary to use only an equal to sign with these kind of joins. You can use other greater than, lesser than signs as well with these different kinds of join. So these are the basic kinds of joins, and I hope that you found this tutorial useful and it helped you in understanding the concept behind the different types of joins that occur in SQLs. If you have any queries or any comments, please feel free to put them down in the comments section. Also, if you like this video, please do not forget to subscribe to our YouTube channel, and I'll see you next time. Thank you and goodbye.